learn about what are called as spherical mirrors. So why this word spherical mirror? When I say the word mirror, we always imagine something we look at daily or hourly or 3 or 4 times a day in our house. So we look at our image, right? What we see there is a plane mirror, right? And what happens in a plane mirror? In a plane mirror, your image is flipped left to right. Okay, it is inverted left to right, but it is erect and it's of the same size. What is meant by erect? You don't appear, twisted and all that. You appear erect, and you appear of the same size. You don't appear tiny. You don't appear large. So we are not worried about plane mirror here. We are worried about spherical mirrors. So when you speak about spherical mirror, there are two types of mirror. So this you would have seen, would have been told in your school to look at your spoon. This is the curved inside curve of the spoon, which you call as concave mirror. And this particular surface, when you take it away from you, you appear a little diminished. And when you take it near you, you appear a little enlarged. Now, this is the back side of the spoon, which is known as a convex surface. Now, if you are confused about all these terms, don't worry, we'll sort it out in the forthcoming minutes. Okay. So, concave mirror and a convex mirror. So, image formation are all the same. Are they the same in a concave and a convex mirror? Of course not. So, you speak about various properties of image. You say your image. Okay, first let us see the rules of a mirror. First, rule number one, angle of incidence is equal to angle of reflection. This is rule number one. Rule number two, angle of incidence angle of reflection and normal are on the same plane. So understand, it is the angle of incidence, it's the angle of reflection, it is not the incident ray and it's the reflected ray. So what is angle of incidence? Suppose I have a mirror and my ray is incident like this, and perpendicular to this surface I have what is known as a normal, and this is my angle of incidence. This is my incident ray, this is my angle of incidence, and this is the angle of reflection. So you see the angle of incidence is equal to angle of reflection. They are all lying on the same surface. So I have a board here. Let us say they are all lying on this board. So they all lie on the same plane. What is a plane? Plane is a two-dimension. Is it applicable only for plane mirror? No, it is applicable for all the mirrors. Now, without much ado, we will pass on to what is known as a spherical mirror. Okay. Okay. I'll come back to this a little later. First, we'll see what is a spherical mirror. Now, I have a concave and a convex mirror. Let me first take a concave mirror. So, concave mirror. Now, this part is the reflecting surface of the concave mirror. This is the back of the concave mirror. Concave mirror is called a spherical mirror. So is convex mirror. So, why are they called as spherical mirrors? Now, I am extending this. And I'm sorry, it looks like more like a tear. Roughly you can call it a circle. If I extend this curve, you will complete a circle. It looks like a hollow sphere. It looks like a hollow sphere. It's a closed sphere. It looks like a hollow closed sphere. Okay. And since it looks like a sphere, these are known as spherical mirrors. They're not spheres as such, but since they are necessarily a part of a sphere, they are known as spherical mirrors. Okay. Now, there are various terms in the mirror reflection which you have to know. Okay. What are the various terms? Then we will see the nature of an image. Then we'll see how the image is formed in a concave mirror. Right. So, first term you will have what is known as focus. You will have what is known as radius of curvature. You will also have center of curvature. You will also have what is known as principal axis. These are terms which you may or may not be familiar, but let us run through them to understand. Okay. Now I have a spherical surface here. I will have a center of the spherical surface, right? I do have a sphere where this is a part of the sphere. This is the center of the sphere, and this center of the sphere lies outside the sphere. You know that, right? The center of the sphere lies outside the sphere. And when you draw a line from the center of the sphere to the lens, to the mirror, I'm sorry. This line is known as principal axis. This line is known as principal axis. This radius, this is R, right? From here to here, it is known as R. It is, sorry, you clean it and write it here. This is your radius R. From here to here is your radius R. This is your radius of curvature. This is the center of curvature, and this is the radius of curvature. So we have seen principal axis, we have seen radius of curvature. Let us then see what is focus. Center of curvature, radius of curvature, principal axis, what is focus? Generally, we'll call this P, principal axis. Generally, focus lies halfway from the center of curvature to the pole. This is called the pole, which is on the principal axis. So, focus generally lies halfway from the center of curvature to the pole, which means somewhere here. Let us say this is at 0 centimeter and this is at 6 centimeter. Then your focus will be at 3 centimeter. Halfway from P to R, that is necessarily, remember, your focus F is equal to generally R by 2, where R is the radius of curvature. What is focus? Is a question. So focus is a point generally where lines tend to converge or diverge from. Then the question is, what is converge and what is diverge? So, okay, let us just see. Let us say there are so lot of rays coming in from somewhere. The meeting here. All these rays are coming and meeting here. They are all meeting here. They are all converging together. So this is convergence. So what is diverge? I have a point from which rays are moving out, radiating. This is diverge. So your concave mirror is a converging mirror. And your convex mirror is a diverging mirror. We will see more of it as we proceed. So how will a convex mirror look? Same curved surface. But this is the back of the mirror and this is your reflecting surface. On the contrary, when you look at concave mirror, this inside part is the reflecting surface. Outside is the back. Here, this inside part is the back of the mirror and here you have the reflecting surface, the bulge. You will also be asked to remember whatever caves in is a concave mirror. The other one is convex mirror. So we have seen what is focus, what is radius of curvature, what is the center of curvature, and what is the principal axis. Okay. We have also seen what is converging and what is diverging. We will understand more of it as we discuss the image formation. And we will also see image nature where they will say same size, you know, is same size. Our same size, how you stand, like in the plane mirror. Sometimes they say your image is enlarged. Sometimes they say your image is diminished. Well, first, let us see what does this mean. Of course, you know these two terms. Enlarge is getting a larger image of yourself. Diminish, getting a tiny image of yourself. Where do you see this? When people are using mirrors for shaving purpose or for makeup purpose, you look at those special mirrors, the face will appear enlarged. Okay. So generally, this enlarged image we just saw right here. What gives an enlarged image? It is a concave mirror, right? Enlarged image is generally given by a concave mirror, that which converges everything. Diminished, mostly this diminished image is given by a convex mirror. So where do you see this? Our rear view mirrors. Rear view mirrors, you see a car which is coming at the back looks very small. Am I right? That is a convex mirror. So we use all sorts of mirrors in our daily life. We use a plane mirror, we use enlarged mirror, we also use, we use concave mirror, we also use convex mirror. Sometimes, now these are the sizes of the image. Sometimes they will say your image is erect. What does image mean erect? Standing straight. My head is where it should be. My leg is where it should be. Sometimes they will say the image is inverted. So if this is my object and this is my image, it is erect and same size. If this is my object and this is my image, it's very rare. This is again erect but enlarged. If this is my object and this is my image, it is erect, diminished. Do we have all these cases? Of course not. I'm just telling you for understanding. If this is my object, right? And sorry, and let's say this is my principal act. This is my image. Then you say your image is inverted. Your inverted also may be enlarged. Your inverted also may be diminished. Okay. Now look at this. I'll go back to this image. This is a plane mirror ray diagram. So you see from object, maybe that is me, the rays are incident here and they are sent back. Now look at these two rays that are being sent back. They move like this. Suppose I go on extending these rays. Do they meet at any point? Of course not. But generally, the rays meet at some point to form an image. Now, how do you make the rays meet? You start extending them to the back of the mirror. So, they meet at the back of the mirror, which means in a plane mirror, your image is found at the back of the mirror. Do the lines really intersect? They don't intersect. So, you get what is known as a virtual image. Virtual, it means you are projecting it in such a way that it will meet somewhere. Then it is a virtual image. And what is a real image? Real image is got when two rays intersect like this. So suppose one ray is coming like this, right? Another ray is coming like this, and they intersect here, right? So here one image will be formed. That is known as, we'll see as and when we go, we'll see. That is a real image. Real image is got by intersection of rays. Virtual image is got by projection of rays. So if you want to understand more about it, we'll see image formation in a concave mirror formed by image formation in a convex mirror. So image formation. Concave. So when you speak about image formation, there are various positions where you can place the object and the image form will vary based on the position. So position 1, we will see all the position in this page. So position 1, this is my concave mirror. We'll have a comprehensive table later. This is pole P of the mirror and this is center of curvature C of the mirror and this is radius of curvature R of the mirror. The first case, let us say your image is beyond C. Okay, sorry, your object. What do you mean by object? It may be you, it may be a spoon, it may be a pencil, it may be anything. Your object is beyond the center of curvature. So, how is the image formed when your object is beyond center of curvature? So, before discussing this, there are certain rules when you speak about image formation in concave mirror. Convex also is almost the same. A ray, sorry, a ray that passes through focus after reflection is parallel to principal axis. Okay. Second, a ray, sorry, I keep doing this, that passes through C, that is center of curvature, after reflection comes through C. Again comes through C. Third, a ray that passes parallel to principal axis. After reflection passes through focus. If you see 1 and 3 are identical, I mean, but with a small difference. Let me check for the fourth thing. Okay. A ray that is incident on the pole, sorry, a ray that is incident ray on the pole is reflected with the same angle. Okay. Now, let us take the first case. What is my first case? The object is beyond C. So, we can consider any two rules. So, I will take some rules which I like. This is not R, I'm sorry. This is the center. I'm sorry, I just made a mistake. This is F, isn't it? So, now rays from the object will fall on the mirror and they are reflected back. I can take any two rays to find out where the image is formed. So first I will draw an image. What am I doing? Okay. This is my incident ray. How is my incident ray? My incident ray is parallel to the principal axis. So after, now let us see what rule is this. A ray that is uh, parallel to the principal axis after reflection passes through the focus. So after reflection, how should it pass? It should pass this. Right. Now, I will take rule 2. A ray that is passing through C will be reflected back in the same direction. Now, how do we find the image? Now, this image, this ray goes like this. This ray goes like this. Where do they intersect? They intersect here. So, from here, this is where it is formed. So, how is my image? I'm sorry. How is my image? My image is ulta. How is my image? My image is ulta. It is turned. Not only that, so first thing is my image is ulta. It is turned. Second thing, first thing is actually it is real. Why is it real? Because it is formed by intersection of two rays. So it is real. Okay. So what will we write? We will write it is real It is inverted. Okay, we may have to go to the next page. And see, look at the size of the image. It is not the same size as this, right? So what do we have? It is diminished. Real, inverted, and diminished. So this is the first case which we have seen. Okay. So I have all the cases here for you to give one by one. Now let us look at the second case. Second case. So here your object is beyond C. So where can your object be next? On C, right? So the second case, you have an object. Sorry. Okay. So this is my C. This is my F. My object is on C. I can take two cases. First is what we did earlier. Object passing parallel to principal axis after reflection will pass through focus. Rule number 3. Pass through focus. Then I will have rule number 2. Object, because I cannot have the ray passing through center. So I will have rule number, I cannot have rule number 2. So I will have rule number 1. First we use rule number 3. Then I'll have rule number 1. The ray passing through focus, it is hitting here. After reflection, how will it go? It will go parallel to the principal axis, rule number 1. So, you, sorry. So what do I do? Use my board properly. It is reflected back like this. Okay. So, what is happening here? My object, a ray from my object falling on this is reflected back through the focus. A ray that was passing through the focus is reflected back. So you may not get an exact thing. Actually, this will be my image. So you can do a jugaad, draw this and then draw the image in such a way that your image is real, inverted, and actually it is same size. When you generally draw, you may, make some mistakes. So you can use a trick wherein you can draw the image like this. Okay. So here you have this fellow and this fellow goes like this. Then what do? You adjust the angle of this so that, yes. Okay. So the incident point has to be exact. You bring it here. So what do you have? Real, inverted, and same size. Now you'll have a case 3. We have here. I have here. This means C. This is my. I'm sorry. This is not midway. I changed. This is my principal axis. This is my pole. This is, let us say, F. This, let me say, is C. So what is the third case? Yeah, my third case is object place. So this object fellow is coming forward, forward, and forward. So initially it was beyond C. Now then it was on C. Now this fellow has moved to somewhere between C and F. Okay, now I have this. So again, we will apply any two rules. Okay. So first rule is same. Object passing parallel to principal axis will go through F. Now what is the second rule? I will use rule number 1 and 3. Okay. It cannot pass through C, right? Obviously. So object passing through focus, what will it do? It will go parallel to principal axis. So they meet here. So what do I have here? I have an image. They meet, right? Both the images meet. I have an image. They meet. So your thing has to be real. It is inverted. Now look at the image. Actually, it will be. This is a little bigger than this. If I draw it properly, actually, and it is magnified, inverted and magnified. This is case 3. Let us go to case 4. 4. This is my focus. This is my C. So where have I have placed the object beyond C. I have placed it on C. Then I have placed it in between C and F. Now it has to be placed where? It has to be placed on F. My object has to be placed F. Okay. Now I can take rule number 1, rule number 3 here. The ray that passes, sorry, the ray that passes parallel to principal axis after reflection passes through focus. I can take this. This I cannot take. A ray that passes through focus, it cannot. This also I cannot take because ray that pass, I can take and project it back, but I don't want to confuse you. I will take rule number 4. I will take rule number 3 and rule number 4. So ray that passes through the principal axis will go through the focus. That is the first thing. Then what is the second thing? A ray that is passing, that is incident on the pole, will be reflected in the same angle. Yes, what? Sorry. A ray on the pole, this is not R, on the pole is reflected with the same angle. This is rule number 4. So a ray is incident here. This is reflected with the same angle. So if you go on, extending these two, they will meet at some point very, very, very far away. But they are going to meet, so it is real. And it is again ulta, it is inverted. So when they meet, it will be somewhere far away. Let us just assume they are meeting somewhere here. They are not still not meeting, you see. How will the image be? Highly magnified and it is beyond C. So what is the image here? Highly magnified. Now let us take a last case. What is the last case? So my image which was here, my object which was here, moved here, then it moved here, then it moved to focus. Now, where should it move? It should move somewhere here. This is my object. Not my image, this is my object. So, rule number 1 and 4. So, rule number 1, this fellow is incident here, this ray. How does it go? It has to, I'm sorry, it has to go through the focus, right? So, this. Now I will take rule number 4. What is rule number 4? Which is incident on the pole is reflected with the same angle. Now these two are going towards each other. Now look at these two. They are moving away from each other. Can they meet here? No chance. So how do you make them meet? Project them backwards. So they meet somewhere here. So now what is the, now this is only a little different. You have projected the rays. In all other cases, see, the rays meet each other. When the rays meet each other, the image formation is real. When you're projecting the rays, right, like you're doing here, it's not real. Your image formation is virtual. This is totally different. Not only that, you see, it is not inverted, but it is erect. If it has come this side, flipped, it would have been inverted. Now it is erect. And what is the last one? Magnified. It is highly magnified. So, do we have a table on this? Of course, we have a table on this. So, look at this. You learn of this table, and you should be able to do some jugaad and draw the image formation yourself for a concave mirror. So, we have seen concave mirrors. Should we be seeing convex mirrors? Of course, we should be seeing convex mirrors. Let us go on to convex mirrors. Okay, now let us go into convex mirrors. See that it is, this is your, okay, let us go into convex mirrors. This is your reflecting surface. This is the back of the mirror. Okay. So, if I extend this, I will form a sphere here. So, which means this is the center of the sphere C and this is my focus F. There are only two cases here, object at infinity. So, the rules, what are the rules? The rules are same as that of concave mirror. So, let me take the rule wherein an a ray that is parallel to principal axis, okay, will go through focus. Actually, when I say will go through focus, obviously it cannot come here. But the angle of inclination will be such that it will appear to come from focus, meaning, so if it has to go through focus, this has to be the case, right? How will the ray be reflected back? It will be reflected back. It will appear to go through the focus. Case 2, a ray can pass through C and come back the same angle. So what will I have here? I will again have C. This will pass through the same angle. Where do these rays meet? These rays meet here. One kuti, very kuti, see. So what is here? My image is virtual. Why is my image virtual? I have got it by projecting. My image is formed behind the mirror. What is my second one? My image is erect. And my image is diminished. These are the properties. Now, second case. Now, let me go into the second case for convex mirror. Okay. What is the second case? Not much different from the first case. So, I have a surface. This is the back. This is the reflecting surface. I have F and I have C. I have the image fellow here. Sorry, the object fellow here. Again, the same rule. Where will it appear to go? It will appear to come from F. So actually it is reflected back like this. Sorry. Reflected back like this. Rule 2. When it passes through C, it will appear to come back from C. Again, where is the intersection? Intersection is here. What is the image nature? Same, virtual. It is erect and it is diminished. So when you have a convex mirror, you don't have much to choose. Your image is virtual, erect, and it is diminished. Okay, now let us see a couple of uh, questions from your question papers, right? Now let us see sign convention and a couple of formula. And we'll work out just two problems. One problem and one conceptual question. The rest we can do later on. So I have a curved surface this way, a concave mirror, let us say. I have a curved surface this way. So everything to the left of the mirror, this side, is negative. And everything to the right of the mirror is positive. Remember this, everything to the left of the mirror is negative, everything to the right of the mirror is positive. I will give you one formula today. So when I speak about image and, object and image, The distance between object and the mirror is generally called as, labeled as u. Distance between object and mirror is generally u. And the distance between the mirror and the image is always v. Remember, distance between object and mirror is u, and distance between object and the image and mirror is, like, let me say, if this is my object, this will be u. Okay, this is negative. Remember, if this is my image, this is v. I'm just telling you an example. This is also negative. Please remember that. Okay, so let us see one formula. 1 by u plus 1 by v is equal to 1 by f is a formula. What is u? U is the distance between the mirror and the object. What is v? V is the distance between mirror and the image. What is f? F is the focus. Of mirror used in the following situation: headlights of a car and rear view mirror of a vehicle. Rear view mirror of a vehicle, we all know, is easy. It is a convex mirror because we have been discussing. The image you see is erect and it is diminished. You don't have an erect and a diminished image in concave. You only have erect and diminished image in a convex. Let us go back to this concave. See, erect, virtual, inverted, real, inverted. Only one erect is there. It is virtual. It is magnified. But what is the nature of image in a rear view mirror? It is erect, no doubt. It is not magnified. It is diminished. Where do you get a diminished image? You get a diminished image only in a convex mirror. See, once you keep on learning this, it becomes a part of it. What about headlights of car? Whatever is given out is rendered parallel. So what is happening in the headlights of a car is, there is a concave mirror and there is a bulb that is focused. Okay, this is the focus point. So what happens? The light that is passing through this bulb when it's incident is rendered. What happens when it passes? It passes through the focus. I'm sorry, this is not the way I draw it. Light that is passing through the focus. How is it rendered? It is rendered parallel to the principal axis. Similarly, light that is passing through the focus is rendered parallel to the principal axis. So, you have a concave mirror where the light goes through the focus and it is rendered parallel to the principal axis. Just imagine, how to, you need not even draw this much or think this much. Light that is coming out of a headlight is parallel, or a torch light is parallel. Parallel light that is coming out. When do you have a parallel light that is coming out? A parallel light means it is going parallel to the principal axis. When can that happen? That can happen only in a concave mirror. So you can blindly say it is a concave mirror. Let us work out one numerical problem. Numerical problem. In this also, I'm not doing the second part because I've not spoken about magnification. 10 centimeter long pencil, I'll ignore this as of now, is placed 5 centimeter in front of a concave mirror. So I have a concave mirror. This is my back of the concave mirror. Where do I place it? 5 centimeter. Where is it position? I really don't know. It's 5 centimeter. That is the distance between the object and the mirror, which is u. So u is minus 5 centimeter. Why is it minus 5? It is minus 5 because it is in the other side of the mirror. We also have the radius of curvature r, which is equal to 40 centimeter. This is also minus because this is also on the left side, because when I complete a sphere here, the radius will also come this side. So r is minus 40. I need to find out position of the image, which means I need to find out v. Where is v? So I know u, I know v. What is the formula that connects v and u? 1 by u plus 1 by v is equal to 1 by f. I don't know f, but I know r. What is the connection between r and f? We already said f is equal to half of that radius. That is, between center of curvature and the pole, the focus is situated just bang in the middle, which means f is equal to r by 2, or you will say minus 40 by 2, which is minus 20 centimeter. Now let us substitute here. I know f, I know u, I need to find out v. 1 by u, what is it? 1 by minus 5 plus 1 by v is equal to 1 by minus 20. So I will keep 1 by v to one side, 1 by minus 20 I will take this fellow to the other side. T will become 1 by 5. So my LCM is 20. So, okay. So you will have a minus 1 here. Okay. There is a minus here. So you'll have a minus 1 here. Here you have a plus. This is 4 times 4. So this is 3 by T. So 1 by V is equal to 3 by 20. So what is V? V is equal to 20 by 3, which approximately works out to be 6.67 centimeter. Now let us see. Your V works out to be 6.67 centimeter. So where is the image formed? Your answer is positive. So where will the image be formed? Let me draw it here. My image is going to be formed since my value is positive. Where is my image going to be formed? My image is going to be formed beyond the mirror. Now let us go back to our table. Look at this table. Only one point it is, or let us go to the diagrams. At only in one case it is formed beyond. When the object is between focus and the mirror, only then it is formed at the back of the mirror. Which means where should to draw a ray diagram, our object should be, if this is the focus, right? Our object should be somewhere here. When your object is somewhere here, what did I tell you? So this goes like this. And after reflection, how will it go? After reflection, it has to go through the focus. So what will you do? You will project it back, right? And what is the second case? The second case is incident here. After reflection, it goes in the same angle. Again, you will project it back. So your image, this will be your ray diagram. It's magnified. So the magnification we will see in the next class. Okay.